Hey y'all, welcome back. Good to see you again. Thanks for making it, and hope you all well. Behold, we have a HK450 in front of us here. Look at the state of this thing. So there's a little bit of story behind this one. One of my clients, Keith, he often goes to garage sales and estate sales, and he picks up vintage stereo equipment. He brings it to me and I work on it, and we're both happy. But he found this at an estate sale. The story was that he asked the person selling at the sale if he had any silver-faced stereos, and the guy thought about it for a bit and said, "Oh yeah, I do actually. I was back in the shed here, or back in the Quonset or whatever." So he goes in the back and he pulls this thing out. And the volume of dirt and dust on it is staggering. Look at it. It's going to be mostly cleaning. So Keith phoned me and he says, "I got this HK and it's pretty rough. I don't know if I should even bring it to you." And I says, "Oh yeah, bring it over. We'll do something with it." And he's going, "Well, I don't know." I says, "Oh yeah, you'd be surprised." So here it is. I had to talk him into bringing it to me so I could work on it. But it does need a lot of work. Aside from cleaning, here, let me remove the camera and then we can have a good look at this. Okay, here's a block of rubber that fell out of here. It must come from somewhere inside. It had no screws for the lid. The lid was loose, and I'm just gonna. It's a little bent up too. I gotta straighten it some. It's filthy, and you can see there's a lot of smoke staining inside the entire unit, so it's probably a lot of smoke damage inside too as well. So inside it's mostly just filth and some corrosion from but the main thing inside here I see right now is the dial cord is all disconnected. I don't think it's broken. I think it's just disconnected for whatever reason. They had the lid off and maybe somebody bumped the string on the drum or something. Or maybe it came off on its own and they were attempting to fix it. Who knows? But we don't know if this thing works or not. I haven't plugged it in. I'm kind of hesitant too with the amount of dirt and filth. I think I'm just going to blow it out first before I do anything. And then we'll give the power supply a check over before we power it up. So we'll find out if it works or not. We don't know yet. It'll be a nice unit once it's running again. Okay, here's a good look at the front. It almost looks like it's mostly nicotine glaze. The buttons are functioning, nothing's stuck. Knobs are turning. Everything's working that way. It's just filth and a little bit of water damage. Looks like there's a big puddle here. I think it leaked inside. I think there's some staining inside as well as on the outside. So I think this is mostly just nicotine glaze and filth from being in a hostile environment. Here's a look at the other side. Everything seems to function normally except for that. And let's see here. We'll have to figure this out. Oh, there it goes. I think something's broken in there. So the AM bar antenna is intact, which is good. Usually these get smashed in shipping, or people use them as a handle and they get pulled off. Or about 50% of these are busted, so it's nice to see it's still there and looks like intact. So we got phono, auxiliary, one tape loop, output for another tape loop. There's no input for this. Okay. 2 sets of speakers, right and left circuit breakers. That's pretty common for these receivers of this era. Input for the antennas, 1 courtesy outlet, and that's pretty much it. I think they might have had a DIN connector here as a... Yeah, I think there's a printed circuit board back there with, it's not populated, but it's punched out and etched for a DIN connector. Doesn't appear to be too much fusing in these, so I'm going to check these 2 fuses. This one looks intact. I'm going to see. Oh, it is not. Both fuses are open. Okay. So I guess powering it up won't do as much good. We're going to figure out what's going on, why those fuses blew. So on the bottom we got 1, 2, 3, 4, 5, 6 screws missing. And some of them, well, the rest of them are loose. So we definitely know somebody's been in here playing around. We don't know what they did or if they did anything at all. Maybe they just had a look. But I'm going to take this and do some, just wanted to open up the bottom, have a look. Looks like somebody's been soldering on these transistors maybe. Maybe they're touching up solder joints. That's what it looks like here. Okay, I'm going to blow the dust out of this thing. Before I go too much farther, I want to see what's wrong with this amplifier. Now, I think, like I confirmed before, we have 2 blown fuses. That one's blown. That one's blown. And those 2 fuses come straight off the secondary of the transformer. And they go to the diodes here. So let's check some of these diodes, make sure that they're all good. The bridge rectifier, that one's good. That one's good. That one's fine. That one's fine. That one's good. There's another bridge rectifier here. Good. Okay, everything's good there. Actually, there's a couple diodes down here still, so let's check these ones while we're at it. Everything's good. Okay. Also, while I'm here, I'm going to check these 4 emitter resistors and see if any of them are open. Good. Very good. Okay, all the emitter resistors are good. Now, let's check these 4 transistors, because that's the only other thing that could short circuit and blow the fuses in the power supply, unless we have a dead cap. But let's have a look at these transistors. Somebody's definitely been working on this. You can see a lot of flux residue and soldering. Somebody cut a trace here and then they jumpered it with a wire. Lots of flux residue, or somebody's replaced transistors in this, it looks like. And I was looking at the back here and there's a sticker. You can't really see it very good, but it says it's from an electronic repair shop, electronic analyst. And these guys are still in business today at the same location. I just looked it up. Well, actually, yeah, I think it's the same location. So it was in for service. Let's check these transistors. It's good. Good. Everything checks out fine. There shouldn't be any reason why that would blow. So let's repopulate those fuses and see, give it a try. Alright, I checked with an ohm meter from ground to the power inputs for these fuses, and there's no shorts to ground. It was actually measuring up in the mega ohms. So I'm going to put two 4 amp fuses back in to these fuse holders, and we're going to power it up. See what's going on with this thing. I think it might have had maybe bad power or something. Okay, so let's plug this in. Wow, that's all messed up. Okay. We have our current meter here. I don't know if you can see that. Without the glare, let's turn it on. I'm drawing normal wattage. No fuses blue. So the amplifiers are working. Just a really dirty, scratchy volume control. Okay, let's see if we can get a... where is the... We're on phono right now. A lot of hum. Tape monitor. This is the balance. Okay. Treble. Seems to be working. Bass. Working. Everything's working, it seems. Okay, let's switch this to FM. Okay. So far so good. That's FM stereo. FM AM. Sounds like it's working, but we're not getting anything. Okay, 30 watts. Everything seems normal. So let's shut this off. Now I noticed somebody's had this tuning capacitor apart because it only has probably half of its range of motion. It's fully open. And when you try to close it, it stops about halfway. It locks up. And I think it's because somebody pulled the mechanism apart here and didn't put it together right, because there is a mechanical stop thing here that is supposed to stop from rotating too far, and I don't think that's all buggered up. I'll have to deal with that. Now, everything's looking good so far. Let's just finish cleaning it up. I'm going to start checking a few caps in the power amplifier, and we'll see what we have here. We have some old caps, these TK caps. These are the blue ones, not the green ones, so I'm not sure how these ones are doing. Big mess here on the power amplifier board with the soldering, and things are bent over, and looks like somebody really had a hard time with this. So I'll take this all apart and clean it. Okay, I'm just doctoring up this variable air capacitor here, and it's fully closed. This see, what happened was somebody pulled this shaft out. This shaft is not anchored in any way. Here, I'll show you. I'll take it out and show you. See, the shaft is just pushed in, and there's nothing holding it. I think they have a groove there for a C-clip, but yeah, good luck on putting a C-clip on there. You'd have to get it in between. But anyways, this thing limits the rotation. You can only get, let's see here, 1.5 turns. And that's the gear reduction of this too, right? So before it was only opening halfway, or no, it was fully open, only closing halfway. Doesn't really matter. Anyways, we're going to fix it. So we need to put this back. So let's put the screw. There's 2 little screws hold it on. And I'll get this in position and just start the screw. Okay. Now I need the other screw. I think I dropped it on the floor just as I turned the camera on. So give me a second. Let me look for it. Okay, I lost that screw, but I found another one that'll work. So it's no loss there. So you can lubricate the shaft if you want. Probably be a good idea to do it while you got it apart. So part of the problem is you can only access the screws when the capacitor's set up for a certain way. Like right now I can do the bottom screw when the plates are in the fully closed position. Can start that screw. Now let's see how this works. Okay. Fully open. Turn it the other way. Nope. Right there. Okay. All right, now it's working. So let me tighten this screw down, because we don't need it loose anymore. Okay, reposition the and the second screw. I need a screwdriver here. Okay, let's tighten these both down. If you have thread locker, it would be a good idea to use that too, because you don't want these coming loose ever in the future. I gotta use my stubby one. Hang on. Okay, tighten that one down. All right, so we've got a full range of motion now. Now the drum. And you're probably saying, well, how do we know where to put the drum back on? Well, this has 2 set screws, right? And if you look on the shaft, you'll see 2 indentations from set screws. So that's probably, there's one right here right now, and there's one on top. So if I went like this, tightened it down, that would be the correct position for this drum. So one of the advantages of having the dial string off is I can remove the front chassis panel and I can do all my cleaning, and this makes it a lot easier. And then it gives me full access to all the switches and pots, and I can clean all these properly. I don't have to fight getting at this because it's all open now. And what I'll do today is I'll just clean all these pots and switches, check their operation, and then from there I can start building this back up again after I've cleaned everything. A lot of cleaning in this job. It seems like it's all cleaning, but it's going to be worth it, I think, in the end. It's going to be it's a nice receiver. So okay, so I finished pots and switches on the front. Everything's done. I removed these 4 pots, cleaned them, and made sure that they were good before I put them back in. And then I did these switches on the other side as well. I'll flip this over. All these switches have been cleaned, including this. This one had cracked solders around the pins, so something to keep an eye out for, I think. And that's about it. The rest of this is pretty straightforward. I'm going to check the ESR on some of these caps, but I don't expect to find any bad ones. Just like on the power amplifier, I didn't find any bad caps, so I didn't change any. Even the main filters were good. So they're going to go back in, and everything's looking good for this. As far as faults, well, we didn't have any faults except for dirty switches and pots and those 2 blown fuses, which still remains a mystery. I don't understand why it would blow unless it got an overvoltage or something like that, or a lightning strike maybe, who knows. But that's fixed, and we'll start putting things back together now, and getting almost done on the cleaning. Pretty much cleaned everything here. Let's see here, I'm still working on the front panel. This is a bunch of stuff that needs cleaning, so I'll get to that. But I think it's time to start reassembly. Hopefully you can see all this. I'm looking at this this light bar here. Now it had this foam, this really soft foam, and this piece was ripped off, so I had to re-glue it with some silicone. I just did some black silicone adhesive and just put it back on. Now this little piece of foam is really rather important, and I'll show you why. It's because these light for the buttons, each button has a shutter, and when you press the button, it opens the shutter, and light floods in from this slot. This slot's cut here and here to coincide with these 5 buttons, and then when it's in position, it shines light down. And when the shutter is open, it allows light to go through, and then it illuminates the button. When you turn the button off, it's supposed to flap shut to close the light off. But that's the purpose of this foam, is it lays there and it acts like a little bit of a spring or a cushion to allow the shutter to close. See, if I open all these shutters and I turn the switch off, they won't close on their own. So, something to keep aware of. If your foam is all disintegrated, you might have to find another piece if it turned to dust. It's not very dense, like it's very, very soft. So you could use any strip of foam, even upholstery foam, I guess, and cut a strip, maybe 3-4 millimeters wide, and just glue it on there, or double-sided tape it, and then it'll provide that for the shutters. Okay, I think I'm ready to restring this dial cord now. I got everything back together. This here I just put as a protector for the needle. The meter, let's put this aside. So, we have our dial string here. It's just been removed and it's not cut. And I did try cleaning it. It was kind of brown and it had it's really stiff feeling, like it was starched. But let me get this untangled now. It's just a big knot. I think it's time to restring this. Let me see if I can do this. I'll untangle this and come back. That knot here I did not remove. Okay. All I removed was the other side. The other side here hooked onto this spring, right? Just like that. And there's our ferrule. So let's start by mounting this drum back on. And I'm going by the old marks I left. We have to do this according to the instructions. Start stringing variable capacitor in closed position. Okay, so we're going to close the capacitor so it's fully closed, and then I'm going by the marks that were left on the shaft from the previous adjustment. I'm just going to put this back on. Oh, if I can, maybe I can't. We have a slight problem, Houston. There's no clearance to put this back on. Let's see if we can move some components out of the way here. See if I can squeak this in without damaging anything. I might have to just loosen a couple screws here on the tuner board and lift the board up so I can put this drum back on. Bear with me. Okay, so I removed, 3 screws, and this now flip, you can bend it up and I can put this drum on. Just gives you barely enough room, otherwise you'd never get it. So it's on there now. Let me just put these screws back in before I forget. Okay, the first step, I want to get this aligned properly. So let's, where is, okay, I can see that where the set screws were set originally. So I'm going to position the drum over those old marks and tighten down these set screws. Now this might be 180 degrees out of sync here because the shaft was pulled out, remember? But we're going to go with this for now. Okay, so this goes like that. Okay, now we're on. And I'm going to follow the diagram starting at step number 1, going out the bottom. I'll put this on the screen so you can follow along. So let's go. Okay, out the bottom, under this pulley. To this pulley here. Okay, and then our dial pointer, which is way out. Yeah, I think I'm 180 degrees out. I think I have to start with the springs at the top. So let's redo this. Okay, just snug these down again. And now fully closed, my springs at the top. Okay. So we go backwards. Go under the drum. Trying to get the delay in the little groove is the hardest part. We can clean that all up after. Okay. First pulley, second pulley, and this is our pointer. Let me attach this. We might have to get creative here. Yeah, seems like I have to slide it. Let's do this. Let's disconnect this string. Slide it. Can't get it on there. Come on. What is holding this? There's a piece here. Okay, there we go. Let me get this reattached. All right, start over. Okay, now we're back on track. Can you see all this? I don't know if you can see all this. So this is number 5, pulley 5, pulley 6. Back this way to the bottom of the tuning knob, 3 turns, 1, 2, 3. Then down to this little pulley that's on an angle. Over to this pulley. This is number 10. Okay, now this is probably the hardest part of all of it. I have to wrap this around the drum twice and connect it to the spring. So I have to do this while it's under a tension. Otherwise it's just going to go spring and you have to start over. Keep my finger here. Let's try wrapping this. I don't have much room to stick my hand in here. This is a poor place for the drum to be. I'll make it look pretty after I'm done. Okay, so I got one wrap. You can take one more. Just want to see how this is. Okay, one more wrap. Come on. Big fat fingers. I suppose it would be a lot more difficult if the string wasn't pre-cut for me. Another thing is the string has a mind of its own. It just wants to go wherever. It kind of pisses me off. Come on, get on there. Okay. Now it looks like we are quite a bit short. I don't think there's anything I can do to strain. What I can do is I can remove this pulley. Let's try this pulley instead. And create some slack. Take this one out. And then I can connect the spring. Okay. Now we've got our slack. We can take this and connect it to the spring, if it'll allow me. Let's do this one more time. Get my last wrap on there. Spring. I know you can't see what I'm doing, but I'm attaching the cord to the spring. Okay. we got that. Let's have a look here. So we got it strung. Bottom goes out to here, up and around, 3 turns, down, back to the top of the drum. So now what we need to do is we need to stretch this out, and we need to put our pulley back in. There we go. All right, let's test this thing. Okay. What's it hitting? This stupid spring is not positioned right. This thing's hitting the printed circuit board. I might have to just move that in a little bit. I'll give it a couple millimeters, a millimeter or so, just to give it some clearance. Okay. Okay, that's one end. This thing keeps getting hung up here. Okay. It's working. I'll run it through, cycle it through a few times, and I'm going to reposition this knot somehow so that it's not dragging on the printed circuit board. I think I probably put it on. This spring is supposed to be more inset. That's a poor design, having it that close like that. Okay, now that it's strung, let's just make sure that these screws are secure. Tighten them down. So that they can't slip. Okay. Now, another thing you need to do is check the position of all these pulleys. They should be angled to where the string is coming from. This one does an angle here, and this one's pretty straight, 90 degrees. This one here is angled as well, but you can't really change it. So just to make sure none of these are bent, last thing we do is we fully close the tuning capacitor. That's where it stops right there. Okay, now we need to slide the needle over the pointer to register on 0. So I'll just slide this. Don't want to be too aggressive with this because you could cut the string right there. So that's fully closed. Maybe a little more. Let's see. Okay, that's good. Then we lock it. We can lock this with glue. I'm just going to use a little bit of hot glue and just lock the string onto the pointer. Okay, it's critical that you get the inside of your glass clean without any streaks or fingerprints or smudges. Use a good glass cleaner. and your dial face as well, and then take a duster and blow out any loose dust that happens to stray, because as soon as you power it up, the light's going to illuminate all those fingerprints and dust particles. You still have some here. Oh, it's on the outside. Yeah, you can't get this clean enough, so put a good effort in to make it look nice. Okay, secure that down. I'll put the sides on. Still have dust on the outside. That's okay. Okay, so we're ready to do our initial test here. Let's try this out. Let's see what we got. Let's set it up. Alright, that's phono. Bit of hum because I have our shields off. Okay, everything seems to be working. Treble, bass, bounce. We have no left channel. Why do we have no left channel? Okay, we got some troubleshooting to do here. We got no left channel. Let's see. FM stereo.
So with the pandemic, and they're especially taking on with the opioid crisis, they'll be working more towards that.
Registration for September.
Tuner is working good. Oh, I got a left channel here. No left channel on phono. We'll have to investigate that. Okay. Let's go back to FM. Sounds good.
I want it to be busy because that means that they're raising a lot of money.
We haven't won from us for the last 30 days. In the
That's odd. Shouldn't be doing that.
What says it would work out to la perquisition. On les écoute.
It's working good. It's picking up some interference though. In stereo. Let's try AM band. We got nothing. Absolutely nothing. So we need some work to do on the AM band. Why do we have nothing? Should be something here. Let me attach an antenna. Still nothing. All right, so we got some work to do. Before we finish that up, though, let's do a power test on everything here, and it's to see if our amplifiers are working properly. So we have no left channel on phono. We have no AM, and the FM is noisy. The FM is working okay. I don't know if that's interference I'm picking up or what. That's scratchiness. Let's see that again. It's on the low end of the band. Now it's gone.
Complète vos informations à l'antenne d'ici radio. Pour d'autres nouvelles, consultez notre site.
Yeah, if I connect the antenna back up, I'm picking something up. It's interference. The strong stations will drown it out. Okay, let's do our power test. Quite a bit of DC on the left channel, so let's measure it here. Here's the right channel. Down around 1 millivolt. Here's the left channel. I got 2.7 volts. Okay, well let's do the adjustments for the zero balance and the bias first before I do anything else. I keep forgetting about that, so let's do that first. This amplifier seems to be conducting more too. The receiver is drawing about 31 watts total, but this side's getting a little warm. Let's set that up. So here's the instructions for the DC offset, zero adjustment. Connect the DC voltmeter to the right channel, left channel, and adjust VR401, VR402 for 0 plus minus 10 millivolts DC. So we can do that now. I think our right channel is already good. It's our left channel that's giving us problems, so we need to adjust which is left channel, which is right. Okay. 404. Okay, so it's that one there. Let me see if I can turn this on. See if we can zero this out. He's going higher. This keeps climbing higher and higher. Okay, we're going to have to investigate that. Okay, so I pulled both of these stabilizers out and test them out of circuit, and they both test identical to each other. So that voltage I was reading has to be something within the circuit itself. I tested a few transistors as well, and there's no problem. Now, I'm beginning to think, I had this fault not too long ago in one of my other repairs. I had a DC balance problem, and I couldn't get it to stabilize. And what it turned out was it was a faulty output device is actually leaking, and it was bleeding current onto the speaker output line, which was throwing the balance, the feedback out of whack. So I'm going to pull these two output devices and test them. I have a feeling one of them might be bad. So let's go there next. I'll put these back in and see if we can solve this mystery. Okay, so I got everything replaced. Replaced the two power output transistors, and I replaced the sneaky leaky driver transistor here, Q418. I replaced it with a D667 and replaced 420. Let's see, let's turn it on and see what we got. Either we're going to have a smoke show or we're going to have the meter showing milliamps or millivolts. We still have what the hell is going on here? Why is this thing still leaking? It's adjustable, but we're still getting 2.5 volts, 3 volts. Something is definitely wrong with this amplifier. Turn the bias up and down. Let me see if we can adjust the bias. So something I noticed here is when I shut the amp off, it does all this wild voltage swings. 20 volts, 17, and then it settles down. When I first turned it on, before it was going to 0, and then once it timed out it went up to 2.5. Alright, I'm running out of patience here with this thing. I've tested everything I think I can test, and I can't determine where the fault is lying, and I still suspect these output transistors, believe it or not, because I did have another pair that tested fine, but they were bad. Now, another thing I didn't notice until just now is we have different transistors here in each channel. Somebody did replacement. I don't know if that was factory or not, but here we got 2SB617, and here we got 2SB618. Here we have a 2SD587. Here we got a 2SD588. So they're very close. They're probably one generation newer, but yeah. So I got them matched as complementary. And I swapped the transistors around. Let's see if the problem stays or if it goes. So let's check here on our left channel again. Turning it on. And yes, it's still there. And the right channel is good. Now another thing I noticed is I have no bias adjustment on that left channel. I can tweedle that part all day long and it won't make a bit of difference. So something going on in the bias circuit that is just not making sense to me. And I've tested everything. I've tested all these transistors, tested the resistors, the diode. Running out of things to test. It couldn't be this long tail pair, maybe it's defective. That's a possibility. That's a very clear possibility. Let me take those transistors out. What are they? They are 2SC1275s, I think. Maybe I'll pull these two out and replace them, and I'll see if the problem goes away. Maybe that's what's going on here. But I have no bias adjustment. It's at 0. I've got 0 current going through the outputs. And I have, if I adjust this trim pod, it does nothing. I'll put my thinking cap on here. Okay, I found the problem. Now it took me a little bit of head scratching and a little bit of determination, because what I was doing is I was poking around, checking transistors, pulling ones out that look suspicious and testing them and finding nothing wrong. I was checking resistors, couldn't find anything, and swapping transistors from channel to channel, nothing was working. So I figured, okay, that's not working. We got to take a different approach here. So what I did is I got rid of my little schematic here that I was working from, and I could barely see it from this little area here. I blew it up so I could work on this. So what I did is I turned the amp on and I started taking voltage measurements on base emitter collector of each transistor. Started writing them down, and then I pulled out the I remember that Harman Kardon has this, and I pulled this out for the voltage readings on all these transistors so I can compare them. So I compared let's see, Q402 and 404, 402 and 404. So the base is pretty much nil, and then we got 0.6 volts on the emitter, it's correct. And then we have plus 30 volts on the collectors, which is correct. And then I went, okay, and I checked this one, that one was fine. And then I checked this one, 408. Base is plus 30, and I got 30.4 here, yeah. Emitter is, where's emitter? 30.6. So it was 0.6 volts higher. And then its collector says -8. And I says, no, I got 31 volts here. But I checked this transistor, it's not shorted. So then I go to 412. Okay, let's look at 412. The base, it's actually shorted and it's used as a diode. Okay, the base is shorted to the collector here. So the emitter, 412, where's the emitter? Minus 30.6, and I had 31.55. And then the collector, 412 collector, is negative 30 volts. I had negative 31. So I had plus 31 volts here, negative 31 volts there. That's 62 volts difference. So what's going on here? And okay, let's look at R432. 432 is standing up and it has a ceramic little donut on the base, so I couldn't get my probe in there, and that's one of the resistors I did not check. But this resistor is open, so that's the cause of the problem of this amplifier. So I'll get this resistor out and changed. It's a 1/2 watt. I can put a 1 watt in there, I guess. It doesn't really make any difference, but I'll get this fixed up and going. Okay, let's do our bias adjustments. Where is my sheet of paper? Let's do the DC voltage zero adjustment first. We're going to adjust VR 401 and 402, and we're going for 0 millivolts on each channel. So let me connect it right here. Let me get my cords entangled. Just having one of those days. Okay, I'm just going to connect it to the output of the amplifier right at the circuit breaker here. If my clip will cooperate. Okay. Let's turn this on. The volume's right down. Okay, let's switch this to millivolts. And we need a tweaking tool. Here's my screwdriver. Okay, 402, 401, 402. Zero. It's very touchy. If you want it plus or minus 10, I'll give them right a bang on. Should actually let this warm up before I do it. Right there. Oops. Let me treat this pot. Very small amount. Okay. Okay, we should have better control now. Keep going down. Now it wants to play in the middle of the... Okay. There. It's good enough. Let's try the other channel. Okay, right channel we can set up it's VR401, connected to the output of this right amplifier. Let's adjust this. It's pretty much 0 right there, 1 or 2. That's good. Okay, let's do bias. Okay, for amplifier bias, we have to connect our voltmeter to the emitter of both Q421, 423. But that's down in here. I think it's a little hard to get your hand in there. So what you can do is you can connect it to the outside of both of these emitter resistors, and that's the same connection. And we're looking through 33 millivolts plus or minus 1. Okay, so let's do the right amplifier first. I don't know if I can get this one. Actually, I'm going to put this one over here because it's easier. And this one I'll do here. Shut up. Okay. Negative 30. Okay. Here's my tweaky tool. So we'll just turn the bias. We want 33. And we were pretty close. Wow. A little touchy. I'm just going to work the pot a bit. Get that deoxide in there. Oops. Try and knock it. I'd rather have it on the low side. See, that's too high. If you got it on the low side, at least you're conserving power. Maybe that doesn't matter to some people, but some people it does. Okay. Here we go. Seriously? 7? Okay. Pretty good. Okay, we're done. All right, so now I got the power amplifier all repaired and dialed in. I want to getting a little warm on sitting at idle. 36 watts is drawing. Anyways, let's test the power amplifier. I have it all wired in for a power test. I have a 1000 hertz signal coming in, 8 ohm dummy load. Let's turn this up. You should be able to see it on the scope. Let's turn this up. Left channel's on top, I believe. Yep. Okay. Where's our clipping right over here? Right there. I can dial it back a bit right about there. It's just still clipping a little bit. I'm going to take it as that. And we have 16.2 2 watts RMS on the output. So I can't remember what the spec was on this. Is it 30 watts channel? I don't know. So I'll let this go for a while and we'll come back and see how it does. Okay, so it's been going for, let's say 2 minutes now. Heatsink's getting quite hot. Well, it's quite warm. I'm not going to push it any longer. I don't think the heatsink is adequate in these series HKs when they put that channel like that. I'm not a big fan of that. Alright, I want to do some frequency tests here. Let's change this to, let's see here, let's go right down. So I check the bottom end on this thing. It stays right flat to like 3 or 4 hertz. It's like right there is 5 hertz and it's flat. If I just increase the frequency, it stays pretty good. Okay, let's go to the top end of the band. I'm doing this test at about 10 watts per channel. So let's turn this frequency up, 7 kilohertz. $21. $63. Doesn't even phase this thing. We're at 93 kilohertz. Okay, let's turn the power down. It's an amazing amplifier. They put a lot of engineering into these things. You know, you can go from 5 hertz to 95 kilohertz and it's pretty much flat across the board. It's pretty amazing. So let's do a square wave test. Okay, 1 kilohertz square wave. Here she comes. It's looking pretty good. Just going to adjust the bass cut, bass boost. That's what you want to see, I think. You don't want to see any weird ringing or anything like that that's going on. Okay. Treble cut, treble boost. You got a good range there. It's flat right here, and that's pretty much at the 1130 position. If I turn it up a little, it looks like I get a little bit of a. That's an artifact of the scope. Okay, let's go up in frequency. Here's 10 kilohertz, and it's looking pretty good. If I touch it up with the treble, you see what the treble does. Treble cut, treble boost, puts it into clipping. That is a pretty good square wave at 10 kilohertz. That is balance control is working. And that's probably pushing 12 or 15 watts right there. Let's turn this down. Let's go up higher. Let's go to 15 kilohertz. 15 kilohertz looks pretty close. Let's go to 20. 20 kilohertz. And we're starting to see the effect of the rise and fall times. Still pretty good. That is really good for 20 kilohertz. It's a fast amplifier. Okay, one more thing we have left to do. We have to sort out this AM radio. It's not working. So let's get it off the test bed here, and then we'll, we'll get working on that. All right, let's sort out this mystery with the AM tuner. So here's the AM section right here on the schematic. We have, it's pretty basic, it's pretty typical too. L251 right here, that's our bar antenna, and it has a number of windings, 3 windings. This line here is the antenna input, and that couples through a coil to ground. So that's how we inject an AM signal into the antenna. This little part here is a tank circuit, and this is to tune the bar and make it resonant at the tuned frequency so that it picks up better selectivity. And then we have lines 3 and 4 here. This is the output to the radio itself. So here down here we have an oscillator circuit, and it's mechanically tied through the variable air capacitor to tune this L252. There's another tank circuit, and this oscillates at a specific frequency. It should be 455 kilohertz above the tuned frequency, right? So if we tune this to 1 megahertz or 1000 kilohertz, we should have 1445 kilohertz on here. That's the theory anyway. So when we turn this on, we hear static, like it's trying to pick something up. I'm going to get rid of the overhead lights. I'm just going to go through the band a bit. Gets really excited on the low end of the band, and then when I go to the top end of the band, it goes really quiet. So I go to low end. So something's happening within the tuner. Something's happening within the tuner. Either this circuit is working. I'm not sure if this circuit's working, but signal is getting in, and it's making that noise. I think the first thing to do is to test everything beyond this point. And then what I can do is I can inject a 455 kilohertz signal right here into the ceramic filter. This is a 455 CL, and it should make its way through and into the IF strip internal to this chip, and it should make it out to the speakers. Now, why? Maybe we got a problem here. Maybe we have broken wires on the bar antenna. That's possible since it's an external antenna. Maybe it got yanked off and wires are broken. Who knows? We could have defective transistor, either the oscillator or the mixer, or yeah, that could be it. Or we could have something else damaged here. This tank circuit here, we don't know if this is even working. We don't know if this is producing a signal. So if I go to R260, now let's see here, where's my output? This is power in, and this would be my output here. Okay, so if I go and tack on to R260, I should get a signal. But first I'm going to inject a 455 kilohertz signal here and see what's going on. Okay, all set up. I got my loop. My loop antenna is going to radiate 455 kilohertz into this area. Let's turn up the volume on my signal generator. Let's turn up the volume on the stereo. Hear what's going on. Yeah, that is putting a very strong signal in. A bad connection here. Hang on. Okay, that's better. Okay, so I'm feeding it a minus 40 dB signal, and it's coming in pretty weak. Turn up to minus 30. That's a pretty strong signal. And there's minus 20. So the IF in the chip is responding. We just got to figure out why we're not getting anything out of our front end. Okay, next test I have set my generator to 800 kilohertz. I'm going to give it a fairly strong signal, minus 30 dBm. We're just going to tune across the band and see if we can find that signal generator on here. There's 800 there, but it's not picking anything up. So we might have a dead oscillator. Not doing anything. Let me try 600 kilohertz. Completely deaf. But it's picking up noise. So I think that is just 455 kilohertz noise. Okay, let's see if that oscillator is running. All right, so I got my probe for my scope connected to pin, the green line, pin 3 of the bar antenna, and that is the return for the oscillator. Yeah, that comes off a tap here on one of the L252. So let's connect this up to the green. You can see it there. Let me get rid of my noise. If I tune, we have no presence of an oscillator signal at all. So let me check the other line, pin 4, the orange wire. Same thing, except that line is now picking up noise. So we got to figure out why we have a dead oscillator here. Could be a bad transistor. I don't want to start tweaking the oscillator coil until I know that it's going to work. So let me go through and check all of these components here in this oscillator circuit. I think that's what our problem is right here. We're not getting any output here. Q252 is a what is it? It is a 2SC 461. And I think those ones suffer from silver migration. Alright, so I went through and I ohmed out all these resistors, and they're all good. They're reading within tolerance. I'm beginning to suspect this transistor's faulty here. I'm going to pull that out next and test it. What I did is I took voltage readings. This is the oscillator, this is the mixer. I took voltage readings of these two transistors. This one here is pretty close to what Harman Kardon says it should be. This one here says it is not. It is way out. And I'll show you why. So for Q252, I should have 1.8 on the base, 1.2 on the emitter, and 4.6 on the collector. And this is what I got on the tuner itself: 0.93, 0.3, and 10.8. So these voltages don't match at all for this transistor. I suspect there's something going on here. I'm going to pull this out. I did a diode check of this transistor. Everything looks fine, but that doesn't mean anything. It could be a fault. So let's pull that transistor and test it outside the circuit. Alright, so I pulled the transistor out, and it tests fine on my little rig here. But that's no surprise because I've tested transistors here before and they come out good. But so it had a gain of about 45. Okay, so I pulled a couple other ones out of my parts bin and tested them, and the gain was up around 75-80. I says, okay, well, so I put one in and I tried it out, and here's the result.
Digital health. So, when we started, I had two.
So it's working now.
Tickets on sale now. Another great way
I just need to
for a cross.
do a tune-up on the dial scale stuff and do an alignment on the AM. And I'll touch up the FM too, because we did have the dial cord off, and the stations probably don't line up anymore with the dial. So let's I'll go through and do that off camera.
From healthcare workers.
But this is, that station should be up here, but it's down here, so that's how far out it is. So yeah, it's nice to see that we've got it going. I'll touch up that alignment and then we'll finish this up. Alright, so there you have it. It's finished. It's all working now. Not quite what I expected. It was very dirty when we saw that at the beginning, and cleaning that was a lot of fun. But we also had a lot of problems too. We had two burned out fuses. These two fuses here are burnt, and these are fuses that between the power transformer and the power supply. I still don't know why those fuses blew. I think it was something to do with maybe an overvoltage or lightning strike nearby or something to that effect. Didn't find anything wrong with the amplifier aside from an open resistor, which took me a while to find. And then we got everything going there. Aside from that, we replaced two fuse style lamps in the dial, and then we replaced a transistor in the AM radio portion, and then we replaced 6 capacitors. These were all on the signal path. These are DC blocking capacitors, different stages of amplifiers, and they all tested inconsistent with each other. Like, they're not balanced. Like, for example, this one and this one are right and left channel, but one was weak and one was still strong, so I replaced them both. And same thing for these. Usually one tested bad, so I'll replace both of them so they're both balanced. Everything's back together now. I think the owner is going to be happy with this one. He had a lot of doubts whether it was even worth fixing, but I think these are worth fixing. These are good performing amplifiers in here, and they're pretty decent receivers as well. They look good too. I like the looks of these. They have the big chunky aluminum knobs and the gray scale background there. It's all backlit. Looks good. Alright, so I'm going to close this one up, and we'll see you in the next one. Take care, and hope you stay well.